Okay, so let's begin with acids and bases. So the first thing that we really need to understand, and you would have been doing in your lower grades, is what is the difference between an acid and a base? So when you were in grade 9, grade 10, when you're learning the difference between an acid and a base, you would mostly learn it in terms of what to look for, like what does an acid look like, what does a base look like, what does it feel like, what is its purpose, what does it do. But when you get to grade 11, the main thing we need to understand about acids and bases is what does the chemical formula look like. Okay, so we don't really worry more about can you identify or can you give us characteristics about acids and bases. Now we're more concerned of if I give you a chemical formula, you need to be able to decide just based on looking at that formula, is this an acid or a base? Okay, so that's what we're going to be really just starting with. So I have a table here with the most common acids and bases that they generally test you on and they expect you to know. So in other words, if they're telling you in the question nitric acid, they expect you to know this formula off by heart. Okay, so make sure you understand this table, you go through it, and you're able to identify the chemical formulas. So just based on that, we're just going to quickly run through it, and then we'll talk about how do you identify the acid and the base. So if you look at the acid names, we can start off with hydrochloric acid, and then obviously we've got nitric, sulfuric, ethanoic, which also is called acetic. So just be aware, whenever there's a slash here, it means that this is another word to describe it. So just know that washing soda is the same thing as sodium carbonate. Okay, just a note there. So the other thing now is, besides having the word acid here, how do you know that when you see this chemical formula that it is an acid? You'll notice that if we go through the acid column here, highlighted in yellow is hydrogen. Okay, and that's important because whenever you're looking for an acid, it has this important characteristic where you're going to see this hydrogen element. And now it's not just hydrogen because you may be looking at, if you look at ammonia at the bottom here, ammonia also has H. But ammonia is regarded as a base. So there's more deeper than just having a hydrogen atom. It actually has a hydrogen ion. So if we forgot what an ion is, remember that an ion basically has a charge. It has an overall charge. Okay, so what this means is, for instance, if I take hydrogen, which is diatomic H2, this hydrogen breaks up into H plus when it gives off one of its elements, right? So what happens is it has an overall charge here, which is a +1, and this is what we refer to as a hydrogen ion. Okay, so if any chemical formula, if any chemical element has a hydrogen ion in it, then it's most likely regarded as an acid. So that's what you want to look for an acid. For a base, let's have a look at this. So for a base, it's less obvious because if we look at the names, firstly, they don't even have the word base in them. But you'll notice that the latter two, NaOH and KOH, these have a hydroxide ion. So if we look at OH, OH takes on a minus valency. So this is referred to as the hydroxide ion. So if you find a chemical formula with the hydroxide ion, then immediately you know that that is a base. Okay, but then you get formulas like ammonia, which doesn't have OH. You get sodium carbonate, which also doesn't have sodium hydroxide, also doesn't have. So how do we know that these are bases? We're going to look at the theory just now, but there's a certain characteristic of these bases when we dissolve it in water that characterizes it as a base. And that's what we're going to look at now. Okay, but again, this table is just for your learning sake so that you are able to identify the most common acids and bases. So, in order to correctly define acids and bases, we have something called the Arrhenius and Bronsted-Lowry theory. Okay, so this is basically a theory that came up to describe or give us a proper definition of what is an acid and a base. Okay, and this is according to the guideline definition and most likely they will also ask you to give them the definition according to this theory. So when you're learning the definition for acid and base, make sure you understand it in this theory. So let's have a look at Arrhenius theory. The Arrhenius theory firstly says that an acid is a substance that produces hydrogen ions or hydronium ions when it is dissolved in water. So firstly, what does that mean for us before we even look at any more theory? This means that if I take an acid, so I take the substance which is an acid and I put it in water. So this is my glass of water and I'm basically putting the acid into the water. What's going to happen is that in the water here, H2O is water, in the water I'm going to get ions forming. So I'm going to get all these ions that form inside the water, and these ions it can be either two things. It can either be number one, hydrogen ions. Okay, so hydrogen ions is H plus, or it could be what they said here, hydronium ions. Okay, so and hydronium ions is H3O plus. Okay, so if either one of these are forming in your products, H plus or H3O plus, then it means you are dealing with an acid. Okay, so that's the definition according to this. I also have another point here at the bottom just to help you understand that. So it says that if you're taking this acid plus water, so that's usually what your reaction will start off with. It would be acid. And remember, it would be a chemical formula now, right? So if you want to imagine it, we can go to the table and let's say we're taking HCl. Instead of having acid there, I'll have HCl plus H2O, giving me my products. Okay, so that's how we're going to write down these equations. You have acid plus water to give you your products. Now, if you caught on to the definition very quickly, you'd realize that your product must always include the hydronium ion or the hydrogen ion, because that is the definition of an acid. So you must always have H plus here or H3O plus in the product. And there's also some other product that forms, which we'll look at examples to find out. So if you want, you can write down a general equation for an acid. I'm just going to do it above here. So your general equation of an acid is that you have this acid plus water, and this must always give you either the H plus ion or the H3O plus ion. And then you're obviously going to have some other product here, which is dependent on whatever substance you started off with. Okay, but this is a general case for acids. Okay, so let's move on to the next thing. Just going to erase all of this. Okay, so now that we've defined an acid, we have the Lowry-Bronsted theory, which is going to define what a base is. So a base is a substance, let's use a different color for this. A base is a substance that is always going to be producing hydroxide ions when it's dissolved in water. So very similar to an acid, but now instead of H plus or hydronium ions, we are going to be seeing hydroxide ions. So you've got your base plus your water, which is always going to be producing OH minus. So if you want to write down a general equation for your base, you're going to have base plus water, which is going to give us the result of, now here it always just has to be OH. OH minus plus something else, and that something else is dependent on what we started off with. Okay, let's write down the acid one here. Here we said it's acid plus water. Must always give us H plus or H3O plus some other substance. Okay, so that is basically where you need to start off with understanding. A base will always have OH, acid will always have these. So once you understand that, we can then move on to talk about this missing component here. How do we find that? Okay, so that is your general definitions according to the Arrhenius and Bronsted-Lowry theory. Make sure you understand and you learn these two definitions based on the guideline. So the next thing we want to quickly look at is something called the conjugate acid-base pairs. Okay, so this is also going according to how the guidelines set everything out. They then start talking about acid-base pairs. Okay, so let's just firstly, we're going to go through the theory and then we'll do a lot of examples on this to understand it just now. But we need to understand that whenever you have an acid, which we denote to be HA, let me just kind of explain this. So the H here, do I have space? Let me do it here. So the H here is your hydrogen ion. Okay, and A stands for acid. So this is not a chemical formula, it's just a representation of an acid. Okay, in other words, let me just show you from the table. If you look at the table, HA, the H stands for the hydronium or the hydrogen ion, highlighted there in yellow, and the A, this A stands for, it can take a placeholder of any element. So it might be chlorine, might be NO3, might be SO4, or it might be that. Okay, so just understand that. So HA is not a compound, it's just a placeholder to represent an acid. So you can even write down here, this represents an acid. So when the acid, which is HA, loses a proton, what do they mean by proton? So the proton here they're referring to is the H plus ion. Okay, we have many names for it. You now learned already that we can call it the hydrogen ion. It's also referred to as a proton. So when this acid loses the proton, before we even carry on reading, what does this mean? If we stop here, you've got your acid. We said that this acid is HA. H is your hydrogen ion, or you can call it now your proton. A is your acid. So if this acid is going to lose the proton, it means it's just going to become A, whatever that was here, plus it's going to end up with H plus there, right? That's what it means to lose that proton. So let's read on what it says. When the acid HA loses the proton, we have something that forms which is called a conjugate base. So something is forming and it's referred to as a conjugate base. We have a conjugate base, A minus, that is forming. Why is it A minus? This is something we need to pay attention to. So let's just quickly have a look at what's going on here.